So, mutation. Let's talk about what it means for something to be the same and what it means for something to change. Once upon a time, we never modified objects. And at those times, a compound object was just the totality of its pieces. There was nothing more to being a rational number than just what was your numerator, what's your denominator. But this view, that the whole is nothing but the sum of its parts, is no longer valid in the presence of change. A compound data object, such as a list, has an identity in addition to the pieces of which it is composed, of its elements. So a list might still be the same list even if we change its contents. So if I have A bound to 10, and B then bound to that same list A. So what happens here? A gets evaluated to the list containing 10, and then B is bound to that list. A is equal to B. If I A dot append 20, A is still equal to B because A is 1020 and B is 1020. B and A were bound to the same list, even though we changed its contents. However, we could have two lists that happen to have the same contents, but are different in their identity. They are not the same. They just might be equal. So if I say A is the list 10 and B is another list 10, A equals B is true. So far, not too different. But if I append 20 to B, A is now 10, B is 10, 20, and these two are no longer equal. They were equal before. We never reassigned A or B to anything, so there's no A equals this or B equals that statements. But it's just that these happen to have the same contents before, so they were equal, but they were never the same. And so, when one changed, the other didn't. Now, how do you figure out whether two things are the same? Well, there's something called an identity operator, which looks like the word is. And the opposite of is called is not. So one expression is another expression if both of those expressions evaluate to the same object. Equality is true if both expressions evaluate to equal values. So any list containing 10 is equal to any other list containing 10, but they may or may not be the same list. Identical objects are always equal values, but not the other way around. So it will always be that 10 is 10. And if A is 10 and B is a list containing 10, then A and B will be equal, but they won't be the same list. When two things aren't the same, changes to one don't affect the other. But C being bound to B means that C really is B. They're just two different names for the same thing. So if I pop something off of C, I've also popped it off of B, but nothing has changed about A. Now, one lesson, something to look out for, is that mutable default arguments are very dangerous. So as soon as you learn about mutation, you have to learn about its risks. A default argument value, when you define a function, is part of that function value, not generated anew every time you call the function. So let's say I define a function f, which takes some sequence s, and by default it takes the empty sequence. And what it does is it appends 5 to that and then returns the length of the sequence s after that 5 has been appended. So you call f, it uses the default argument value, which is an empty list, appends 5 to it, and returns the length of that list, which contains 5. And you get 1. If you call it again, you get 2. If you call it again, you get 3. And that's because every time you call it, s will be bound to the same value. That's how default arguments work. And if that default argument value is mutable, and you mutate it in the middle of your function, then that change will still be around the next time you call the function and you get that same default argument value. So something that looks pretty simple will actually have strange behavior where it's different every time you call the function. And that's definitely something to look out for. In the first call, S is bound to an empty list. And that list is then mutated to contain 3. The next time I call F, S is bound to that same list, which is mutated again to add another 3. And the third time, you get the third 3. There it is. And that's why we get different return values each time, 1, then 2, then 3.